Hey everyone, this is Mustafa from the educational team of MIMSA, and I'm here to talk about the acids basis graph and to help you draw it and understand it better. This graph right here looks extremely scary, and you know what? I don't blame you. It really looks like that, but it's not scary at all. It's super easy to understand. And by the way, a lot of students seem to skip over it or they don't study it well. Um, some teachers like to ask this question, like to ask you to even draw the graph and to explain your answer based on the graph. And this is why I'm making this video in the first place. So before we get into drawing the graph and doing all this stuff, let's just take a step back, right? Let's talk about the very basics before. So the very basics are the three things I'm going to mention here, and they should stay with you in all of these questions, all four of these questions, meaning respiratory and metabolic acidosis and alkalosis. So these are four questions. So, three things. First thing is that you need to establish this equation, equilibrium of the HCO3 again and again and again. This has to be repeated all the time. Write it down or remember it, memorize it by heart. CO2 plus H2O gives you H2CO3 and HCO3 plus H. Right? You see it a lot at this point. A second thing, which not a lot of people really know about, is the simple ratio of HCO3 divided by PCO2 multiplied by 0.24, which is ideally 20 over 1, or the ratio is 20 over 1, which basically means the pH is 7.4. Third thing is to write down the physiological range of CO2, pH, and basic cess. And it's mentioned here, CO2 is 5 plus or minus 0.5 kilopascals, pH is 7.4 plus minus 0.04, and basic cess is 0 plus minus 2.5, and HCO3, though not important for the graph, is very important for other parts of the test. So just memorize it as well. So this is the first part of what I'm going to draw. The second part is going to be the starting point, and the second compartment here is going to be the compensation, and here is going to be the correction. And what do I mean by that? Because in every of these states of the body, we have we start at a problem, meaning metabolic or respiratory problem, which results in an acidosis or alkalosis, whatever the problem is. And then the first thing that's going to happen is that it's going to be compensated. So, for example, if a problem is metabolic, meaning the issue is from the kidneys, then the compensation is going to be from the other side, meaning it's the lungs that are going to compensate. Uh, the exact details are different for every disease, but the only thing that ties them all together is that one, compensation always happens first, then correction after it. Two, um, yeah, I think this like the main thing that ties them together actually is that compensation always follows the starting point, and correction always follows the compensation. Simply. So now, if we were to draw a graph, or that graph specifically, we're gonna draw the y-axis, right, and the x-axis. Simply, the y-axis is PCO2, and the x-axis is base excess. There will be another axis here for the pH, which is going to cover the other half of the square, so to speak. So it's going to be like this. Fair enough. And this will be pH. So first, start off by mentioning or like plotting on the graph the physiological ranges of everything. Meaning in PCO2, it is 5, let's say 5.5 to 4.5. Basic cess would be minus 2.5 and 2.5. Okay? And in the case of PCO2, you just simply draw a line like this. And in the case of basic cess, you can do the same thing, but at the end you will draw a bit limp on that side. And I'll explain to you why. For pH, um, since it's like a since pH by itself takes two planes, it's impossible just to plot all of pH in one plane. So how it's done is basically it goes like this: 7.1, 7.2, whatever, 7.6 here, 7.7. What we're going to be focusing on is again the physiological range. So for now, remove these numbers and focus on 7.36 and 7.44, which is the physiological pH range. Then you draw a curvy line. Oh, sorry. You draw a curvy line that goes like this. And for 7.44, you also draw a curvy line that draws like this. The point is, this line, the 7.36 line, it covers these edges of the square. This is one way I can understand where every line goes. And the 7.44 line, it covers the edges of the right and lower part of the square. So realistically, this is your safe zone. Why is it your safe zone? Because PCO2 is good, base excess is normal, and pH is normal. So this is the perfect place to be in. Though in reality, we know it's not that easy, and obviously, uh, it stands if in case you have a metabolic disorder or respiratory disorder, it will be outside of this circle of this safe zone. Sorry. So let me just remove the highlights so it's a bit less overwhelming to see or to look at. Though I'm going to keep the smiley face just so you remember again, this is your physiological zone. So let's take, for example, metabolic acidosis, meaning an issue with HCO3. So, for example, with terms like metabolic acidosis, you have to dissect the word so you can understand better. So, metabolic acidosis. Metabolic means it's an issue with HCO3, simply. If it's respiratory, it will be an issue with CO2. Okay? But so far from the name metabolic or respiratory, we don't know if HCO3 or CO2 has increased or decreased. So this is where the second part of the disease comes in, acidosis. We know that HCO3 is a base, so if you lower the base, simply it's an acidic environment. So acidosis is decrease in HCO3. So let's plot it on this table here. pH, acidosis, so pH is low, logically. Base excess or HCO3, like we mentioned, that would be lower because it's a metabolic issue, meaning it's an issue with the kidneys. Right. CO2, for example, it is going to be normal or borderline. But for now, just for showing you, it's going to be normal. So how would that look like on the graph? So normal CO2, low pH, and low base excess. Start with the first, start with CO2 and base excess because these are the easiest to plot. So if CO2 is normal, you're going to be looking at this range, right? Sorry. If CO2 is normal, you're going to be looking at that range. But wait, we said the base excess is low, right? That means that you'll be looking over here. Aha. Notice that they overlap there, right? So this is where the first or the starting point is going to be. At low base excess and at normal carbon dioxide. So, right, so let's say you start around here, which is the equivalent of, I don't know, maybe 7.2 pH, which is catastrophic pH, by the way. But you start here. As I told you before, the first step is going to be to compensate it. And that is done by the opposite system. So in the case of metabolic acidosis, the compensation is going to be from the lungs. And this is where the second equation comes in. So remember, this is a ratio, right? And to establish this pH, ideal pH, or the more ideal one, you need to make sure that the ratio isn't too spread apart. It's almost like towards the 20-to-1 ratio. So logically, if HCO3 decreases, what happens here? or specifically here, this decreases in order to maintain this ratio. Um, so logically here, we put CO2 decreases pH. Just because you decrease CO2, pH is going to be borderline normal, or like maybe decrease, but not to like a level that it was in. So for now, let's just put a normal in the squiggly lines, just to say that it's a bit borderline. And basic cess is like you still didn't fix the issue, right? It's not corrected yet, so basic cess stays the same. It's still decreased. So how would you plot that on the graph? Right, we go back here. The only difference is that PCO2 is normal, is low, and the pH is borderline normal. So you're looking at just around here, a point near here. That's perfect. So now we establish our correcting point. Sorry, our compensating point. What about the correcting point? Again, correcting, actually this part of the graph will always be the same, meaning normal, normal, normal. This is the desired result of the correction system. So to achieve normal, 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 basically you have to increase HCO3 and you have to stabilize the CO2. How it's mentioned in the lecture, I'm not going to get into much details, but basically in the case of metabolic acidosis, that would simply mean to either increase your absorption of H2O3 or decrease its excretion. This is like simply speaking. Or in the case of, yeah, respiratory, I'll get into it. So how would that look like? You would start, so CO2 will start stabilizing, base, basic cess will start stabilizing, and the pH will also become more in the normal ranges. So logically, you will take a trajectory like this, and this will be your third point. Now, right, that was for metabolic acidosis, simply. Let's see how it is written in the lecture. Uh-huh. The lecture says something very similar. A metabolic acidosis, which means acute metabolic acidosis. Uncorrected metabolic acidosis, which is around here. So this is the first point, this is the second point, and this is the normal value, meaning the third point. So if you make like, if you just connect the lines here, 1, 2. There's the problem here. You compensate for it in here, and in here you correct it. Let's do, as a last exercise, respiratory acidosis. Okay, so that would simply be, okay, respiratory acidosis. It's a problem with the respiratory system, right? So CO2 would be changed. Acidosis means that there's increased CO2. So increased CO2. Acidosis also means pH is low. Acidosis also, respiratory acidosis also means that basic cess is not really involved. So normal. How to compensate for that? Well, uh, compensation is through the kidneys. So basic cess would increase, pH would be, well, borderline normal, and CO2 would still remain high. You're not fixing the issue with this. So let's try to plot it. First of all, let me just remove this. Okay. So CO2 is high. The pH is acidosis, so it's decreased. And the basic cess is normal. So where does it overlap? Exactly, in here. Or somewhere in this region, basically. So let's say this is the starting point. Okay? Meaning that the pH is around, let's say 7.25-ish. Uh, and you compensate it. It's through basically increasing the levels of basic cess in your body. So this would be your second point here. or compensated point. And once you correct the issue with the respiratory system, it will shoot back to here, or at the upper edges of the normal range. So that wraps up my explanation of the first of all how to draw the graph, and second how to interpret the graph, and third things that you should always keep in mind when you get these questions about acidosis and alkalosis. I hope I helped you, and if you guys have any questions, biochem, physio, any of the preclinical subjects, I'm here to answer, of course, if I'm able to answer them. And if you'd like some of these mini series for any of the topics you don't like, please put it down in the comments or feel free to message me or message anyone from the MIMSA team, or you can even book a consultation with me if you'd like. So, that was all from me, and I hope you have a great day. See ya.